Okay. So, you may find like I have two accounts here, like for this Zoom meeting, because I just want to make sure like I use my iPad to show you how to do the homework. Because for the chapter 10, chapter 13, like last time I used the blackboards, but you can see like I actually changed my office. So this time, and it's actually not that clear for you to say like what I was writing. So I just used the iPad. Then you will be able to just like follow the steps to do the homework. So let me share the screen right now. Okay, so let's talk about chapter 10 first. For chapter 10, we will discuss the weighting problems. And if you have already like review like all the stuffs here, so you probably be able to find like we have a bunch of models. But all the chapter 10 homework, we only focus on the model one here. So you don't have to if you just focus on the problem, so you don't have to focus on the model 2, model 3, model 4. So the only thing like we use like for the homework is model 1. So you need to figure out all the formulas here, and we have a bunch of them, like they represent the different meanings. So first of all, let's go back to the master slides here to give you like what is the symbol, the notations meaning. So you need to figure out a few of them. So you don't have to just like you need to review like all of them, but you don't have to just like remember all of them. Like for the homework, for the test two is still like open notes, so you can just take notes about like the meanings of the notations as well as the formulas. So what you need to focus on like in terms of the homework first, the lambda. So the lambda here means the arrival rate. It means like how many customers arrivals. And the mu here means like the service rate. So it means like in an hour, like how many customers you can serve like in the system. And then you need to take a look with dou here. This is not P, okay? This is the dou. And this is a ratio of total arrival rate to service rate. And also, like we have four important stuffs here. This is actually the answers the homework looks for. So it asks you to figure out how many customers waiting in the system, how many customers waiting in the line, how long like or how long you need to waiting like as a customer in the system or in the line. So those are the four things like you need to calculate. So LQ, and actually for any L, it means number. So it means like average number, average number. And Q here means the crane, so it's the waiting in the line. And while S here means the system. System means like how many customers, the numbers waiting in the system. So this is the differences here. So LQ means the average number waiting in line, while LS means average number waiting in the system, including the customer which is being served. So this is what we have for L. And for any W, this is means time. So this is not number. So this is means like average waiting time, like in the line or in the system. And the same Q here means waiting in line, while S means waiting in the system. So WQ means the average waiting time in line, while WS means average waiting time in the system. So this is like the four things here. And except for this 1, 2, 3, 4, 5, 6, 7, the last thing you need to figure out is P. So P here, this is dou, this is the P. P here means the probability. So the probability of the exactly n units in system. So if this is the Pn, this is means like exactly like how n units in the system, the probabilities of it. If it's P1, So it means the probability of 1 unit in the system, while P2 will be the probability of 2 units in the system. So it depends on like here is like how many units here, like the probabilities in the system. And it's related to actually the last questions for each problem you made for the chapter 10. Okay, so once you figure out all the notations here, let's move to the formula. So for the LQ, it's equals to the lambda divided by mu multiplied by mu minus lambda. And LS equal to lambda divided by mu minus lambda, while this is the double code WS. And you can say that actually for each waiting time, W still like represent the waiting time. So for the average waiting time here, you always need to calculate the waiting number. So this is like how many, this is the number here. And then the though here means this is actually we use as our utilization because this is the arrival rate while this is the service rate. So this is arrival rate and this is the service rate. So you can figure that out. This is actually the utilization stuffs over there. And this is the how we calculate P. So P0 equals to 1 minus lambda divided by mu. And actually any of P, like the Pn here, equals to 1 minus lambda divided by mu multiply the lambda divided by mu, the n squared. But because like n here is 0, so if this is 0, like lambda mu 0 squared, this is equal to number 1. So we don't have this part anymore. So for P0, this is what we have. P0 means the probability of 0 unit in the system. Okay, and n here again, this is the probability of n units in the system. Okay, any questions by now? Oh, thank you. Thank you. Ever since like I start to admit those students in, so and thank you for the remaining. Yeah. Because I focus on my iPad, so I will not be able to see like if there any students waiting in the in the waiting room. So if you find like any students waiting over there, feel free to jump in and let me know. Okay, thank you very much. And then okay. So let's continue. So if you don't have any questions about the notations, about the formula here, let's move to the examples the textbook provides you. And you can check the examples as well, like in this PowerPoint slides too. So okay, so here we go. This is like the example 10.1, the customers in line. So the arrival rate is 15 per hour, while the service rate is every 3 minutes. So it means like every 3 minutes, then the mu equals 2. So this, sorry. So if the lambda, so this is like arrival rate is 15 per hour. So the lambda equal to 15. And it means like service rate is every 3 minutes. It means like in an hour because we consider like per hour. So in an hour, how many customers you will be able to serve? That would be the mu. So if you need 3 minutes to serve one customer and for an hour you have 60 minutes and for each of this customer you need 3 minutes. So the mu equals to 20. Okay, so the first thing you need to figure out what is lambda, what is mu, what is the value for them. And then it asks you, okay, what is the probability that the present level of service for 3 or fewer customers? Fewer cars. And how about like 95% service level? What is the service rate? And for the homework, you don't have to care about this second question. So I don't have any questions related to this part, but you still need to figure out the first one. Okay, so let's move to the answers here. If you wanted to figure out like what is the present level for service of 3 or fewer, that means like you need to serve as like 0 cars, 1 car, 2 cars, and 3 cars. So all the probabilities here is this. And then we just follow the formula here, then we will be able to got like all the results here. Then the percent will be 68.4%. Okay. So you just like calculate like the probabilities. This is the first types of like the questions. It asks you like what is the probabilities, like the level of service for 3 of your customers. And for the homework, this will be like the last small questions for it, but the homework is actually more focused on this. So this is exactly like the homework questions you may meet like for the chapter. So the students' arrival at the administrative services office and an average of 1 every 5 minutes. Okay, so the arrival rate will be, if every 5 minutes 1 students come, then in an hour how many students may come. And for their request, on average 3 minutes to be processed. And the service counter is staffed by only 1 clerk. So this is the model 1 because we only have 1 clerk here. And Judy, who works 8 hours per day and assume position arrivals, which means like those information gives you just like please use model 1 to figure out these questions. So the first question is what percentage of time is Judy idle? The second, how long is the waiting line on average? And third one, how much time on average does a student spend waiting in line? And the fourth one, what is the probabilities? This is what we just like do. So this is raised to P. Okay. So let's take a look about how to do it. First question. And let's go on with the. Okay, so let's continue. So first question is what percentage of the time is Judy idle? And if I change another like the types of questions to ask, this is actually we know like Judy either idle or busy, and if it's busy it means like it utilized, so this is the utilization. And when we talk about utilization, is rho equals to lambda to mu, so we need to figure out like the lambda and mu here. Okay, so for the lambda, it means like the arrival rate, and we know that like every 5 minutes a student comes. So for an hour, we have 6 minutes here. Then every 5 minutes we have a student come, so the lambda equals to 20. While the mu equals to we know like on average 3 minutes need to be take to fill the request for the students. So 60 minutes and 3 minutes to finish, that's 1 student's request. Then it will be, sorry, this should be 12, sorry, and it should be 20 here. Okay. And then so the rho will equal to lambda to 20, and this is utilization. So the idle time will be 1 minus rho. Okay, so this is how we solve these types of questions. Okay. And I will not give you the exact results here, but you can check, like when you do the homework, you always be able to check like if your answer is correct or not. If not, then you can just like get out like with the tips, and then you can check you can insert like your answers again, then you will be able to check it again. So for here is like I will give you like how to do it, but I will not give you the exact answers for that. And you know that like for each of students, the numbers will change. So it makes no sense like I gave you like the results here. So okay. So the second question, how long is the waiting in line on average? And the first thing, like when you do these types of questions, you need to figure out what does it ask for. So how long is the waiting line on average? It is asked for what? It asks for WQ, WS, LQ, LS. So you need to figure out that first. So for these questions, waiting in line, it should be a S or Q. It is S or Q. Any idea? Q. Okay. Yes, it should be Q because it's in line. If it's system, then it will be S. So then it is LQ or WQ. It's L or W right now. L, Shinzo spelled L. How about others? How do you think? W. Okay, I have L, I have W here. Then we need to figure out here. So how long? It's not asking like how long you need to spend. This asking you like how long about this line. Just ask like how many students waiting in line. If it asks how many students, it means like the number of students. So it's really ask for LQ. And for LQ, it equal to lambda squared divided by mu times mu minus lambda. So you just need to insert the numbers here, like lambda equals to 12, mu equals to 20, then you will be able to find the correct answers for LQ. Okay. And how much time on average does the student spend waiting in line? Again, so it is S or Q first. It is S or Q. Waiting in line. It means which one it should be. You can just like put your answers in the chat box. It's waiting in line, so again, it should be Q because S means waiting in system. Okay. And how much time? It talks about time, so it should be W. So for question three here, it asks it actually asks for much time. It means time is W, and waiting in line it means Q. So it asks for WQ, and WQ equals to LQ divided by lambda. So you just need to insert like what do you got here and divided by lambda, which is 12, then you will be able to get the correct answers for question 3. Okay. Then let's continue the last one. So the last question is like asking you what is the probability that arriving students just before entering in the system will find that at least one of the students waiting in line. So it asks like at least one student waiting in line. So it's the same as at least 2 students in the system. At least 2. Then it should be, and then this probability will equals to, we know like if we have, this is the probability, it's P0, this is means like 0 in the system, and this means 1 in the system. And if we use 1 minus those probabilities, we will be able to get this. because this is like the probability like 0 students in the system. This is the probability of 1 students in the system. And if we use 1 minus those stuffs, it means like the rest of the probability. The rest of probabilities will be at least 2. At least 2 in the system. This is what exactly we are asking for here. So the P0 equals to 1 minus lambda divided by mu, while P1 equals to 1 minus lambda divided by mu times multiply the lambda divided by mu 1 square. So this is what we have. And once you got those numbers, then you just use 1 minus those. And then you will be able to get the correct answers for question 4. Okay?
I have a question. Do you always have to use the 0? Do you always have to show the 0?
Yes,
you do.
Because you always need to consider like this is always like when we consider like how many students in the system, they could be 0, like nobody waiting in the system, or maybe 1 waiting in the system, 2 customers or 2 students waiting in the system. So you always need to consider nobody here, nobody waiting in the system. That's situation. So you always need to involve P0, always. Yes, because like this is will be like the full. So we need to know that like P0, which means nobody waiting, and 1 waiting, 2 waiting until the n waiting. This is like equal to 1. So when you consider like at least 2, at least 3, then you always need to consider 0. Okay?
Okay.
Very good question. Any other questions for this homework? So if you check like your chapter homework, like all of the questions are really similar. So the logic is like follow these examples I just gave you. So let me stop share here and change another stopping here. Okay, stop share and let me share this screen for you. And now you can see get that out. Okay, so you can see like the screen here, like for the chapter 10 homework. This is the question 1, and this is what exactly I just gave you. I just like changed the numbers here. And if you go from in like for the question 2, they are actually similar. So it's still asking you like an average numbers waiting, average like the number of customers waiting, or the time waiting, or like the probabilities or the utilization. So they are actually is similar to each other, and all the 4 questions relates to this model 1. So if you figure out like all the formulas and the notations, you will be fine with all the chapter 10 problems. Okay, so all of the 4 questions relates to, I mean, just really similar to the examples I just gave you. Okay. Any questions for chapter 10?
I do have another question. There was a homework. I don't know my notes are all over the place. I'm not sure which problems that it was. You gave, I think it was 10, the second half of 10, and then it had F in the problems. Like I was so confused as to where you got F and how you figured that out.
Where is the F?
I think it was you were explaining it in the second video, the second chapter 10 video.
Second chapter video. So I may need to check that, and I will give you like a feedbacks like after today's meeting, because
There's lots of
what you are mentioning like F there, but I will check that videos and let you know like what does it mean. Okay.
Okay, that would be great. Thank you.
Okay, very great. I will have a forms for you after like I finish like the introduction, like before we. So I just like I'm answering the questions like for the chat box here. So I will have forms like you can sign your names into, and I will share that link to you like before we finish our meetings today. Okay. And I actually it's just like double check because I have the list. Like for the Zoom, they will give me a list about the attendance. So you will be fine. Okay, so any questions for the chapter 10?
I don't have chapter 10 question, but I do have another question. Do we get to see the answers to the first test now that
Yes.
everybody's
Yes.
taken it?
Yes, this is what I mentioned at the beginning of today's meeting. So
Oh, I'm sorry.
yes, all the grades will be posted today. So you probably will be able to see your grade for the test one because I asked my coach like to post that today. And after today, I will reopen the test one, so you will be able to get access to the test one, and I will open the answers for all the questions like you've done. So you will be able to check the answers for the test one, and you will be able to review it.
Okay, thank you.
Yes. Okay, so if you don't have any questions like about the chapter 10, let's move to the chapter 13's homework discussion. Okay. I need to open the chapter 13's PowerPoint slide. Just give me a second. By the way, because like at the beginning, I also like in terms of test one, I also mentioned like I will do a curve, so everybody will add another 2 points for the test one. It's so weird. I will not be able to. Okay. Okay, I just like stop share here, then I can move to. Are you still able to see a screen right now? Yes, okay. So just give me a second. I just need to stop share like for this computer, then I can just share for my iPad. Oh, I haven't sent the Google Form, so I will send that to Google Form later. So I haven't sent that yet, so no worries. I just cannot stop sharing the screen right now. It's so weird. So let me open the PowerPoint slides here so you will be able to see that. Are you able to see the PowerPoint slides right now? Okay, great. So for the chapter 13 problem, it's related to two different types, but three different types of questions. So the first types of questions relates to control charts, and it relates to two different control charts, the P charts or R or X bar charts. And another types of the questions is actually the last one, the question 4. So it asks you about the acceptance rate. Starts over there. So let's begin with the P chart here. So for any control chart, you just need to figure out like, because the chart here is actually with three lines. So this is what we call this one. This is what we call the upper line, upper control limits line. And this is the lower limits line. So you need to find those two. So this is how we calculate. This is the upper, this is the lower. And this is for P chart. And the P chart means like if you have already like reviewed the PowerPoints, actually for control chart, we have 4 different control chart. We have P chart, C chart, R chart, X bar chart. And for P chart and C chart is like when you figure out like, okay, what is when the matrix you choose to measure your process is like the number of defects, you consider all the integers like the discrete matrix. Then all the numbers you connect, probably the number of defects is one. It's probably 1 or maybe 20 or maybe 100. This is all the integer. Then this is like you need to use P chart or the C chart. And if you use like if you are planning to measure the length, the diameters, the weights, and so on and so on. So when you measure it, so you probably get some like continuous number like 1.20, 1.11, 2.2. So if you got those types of numbers, then you need to use the R chart or X bar chart. Okay, so this is like the logic for like which control chart you should choose. And for any control chart, you need to find the limits. So you need to find the upper limits, the lower limits. Okay. And once you got those limits here, then you will be able to just like considering like how to draw the control charts like with those lines, then you will be able to plot. These points here represents the samples. So if you use a chart, the P chart here, this is the fraction defective for each sample you have. Then you just like plot the numbers which represents the samples into the charts and to say like if your process is in control or out of control. So if you haven't found any single points which is out of the limits, which means your process is in control. Okay, so this is how we get the conclusion. And then let's move to the P chart first. And once you figure out how to do P chart, it will be super easy for you to figure out like how to do the R chart or X bar chart. Okay. So for P charts, this is like the matrix you consider is about like the number of the defects. So this is what you got. And for these tables, it gives you a few information like how many samples you have. Like for this example, we have 10 samples. And this is the number inspected, so 300 for each sample. It means like for each sample, it means like you only inspect 1 unit. 1 sample doesn't mean 1 unit. It's actually for this questions here, for each sample, you inspect 300 units. Okay, so how many units you inspected in total? 3,000. Okay, because like for each sample, you inspect 300, then you have 10 samples. So the total number of the units you inspect will be 3,000. And then you just like count. You start to count. Like for sample 1, like you inspect 300 and you find 10 of them are defects. And for sample 2, you find 8. For that sample 3, 9. Sample 4, 13. Until the last sample 10, you have 8. So you just sum all of them together, you got 91. So for that 3,000 units you inspected, you find 91 defects. Does that make sense right now? Like for now, by now. Any questions? Okay, great. So once you got those numbers, then you can start to do your calculation. So this is like the first step, just review all the information you have. This is all the data you need to connect. If you do this control charts in reality, you need to connect those data. Okay. And then step number 2, let's do the calculations. So the first one you need to calculate is the p-bar. So this is the average defect, the infraction defective. So this is the percent, like for all the 3,000 units you inspected, what is the percent of the defective? So you use like the total, like this is the number of the total defects you find. This is like 10 for sample 1 until 8 for sample 10. So you sum them together and you find, okay, 91 in total are defects. And you use 91 divided by all the units you inspected. So you got a fraction defective. So this is the percent about, this is about like 3% of the defects. That makes sense? Okay, so this is what we call p-bar. A short line above this letter, we call this is the bar. So this is the p-bar. And once you got the p-bar, you will be able to find a really important numbers here. We call the SP. So SP equals to a square root p-bar times 1 minus p-bar divided by n. So careful, n here means sample size. So sample size is not the number of samples. Sample size means how many units in each sample. So for these questions, we pick up 300 for each sample. So the sample size is the size of the sample. So the sample size will be 300. Okay, so N here is 300. And we use like what we got for the p-bar and the 300, the sample size, then we will be able to get the SP. Once you got the SP, you will be able to find the upper limits and the lower limits. So upper limits equal to p-bar plus 3 multiply SP. Be careful here. Another stuff's here. So in general, we use Z here. So Z here represents the confidence level. It means the standard deviation confidence level. So in general, Z equal to 3. So this is what we typically used. But for the homework you did, they probably give you exactly numbers. So they probably give you, okay, 1.96, this is the confidence level we use. Then Z equal to 1.96. That makes sense? So let me give you here. Okay. So this is the homework 13. So it asks you to do the P chart and it probably give you, okay, the upper lower limits for the P charts is above 95% confidence. So 1.96 will be the standard deviation. This is your Z. So when you calculate the upper limits, this is Z equals to 1.96. Okay. This is like if it gives you a specific number or the specific confidence level, this is what you need to use. But for here, so for this questions here, because I didn't mention anything, so in general, typically we use 3. Okay, so this is the 3 we use. Then it equals 3 multiplies SP, and the now lower limits is like minus. We just use minus instead of plus. Then you got those numbers. So this is the your upper limits, your lower limits, and this is then you have the fraction defective here. This is like for sample 1, you have 10 defects. You use 10 divided by 300, then you will be able to get your percentage about the defective. Okay, then you just put those numbers into your control charts. You will be able to see this. And if you find, okay, all of the samples, like they just across the middle line here and not a single sample outside the limits, then you probably feel, okay, it's in control. Okay, so this is how we do P chart. Any questions by now?
I have a question. In that example that you have up, where did you get the 3?
Sorry, I cannot hear you right now. You just mute. Okay.
Can you hear me now?
Yes, go ahead.
Okay. In the example that you have up, where did you get the 3 in front of the SP?
Oh, so this is a 3. This is a SP. You need to use both of them because if we back to like the formula here, the upper limit is equal to P bar plus Z multiply SP. Okay. So in general, we use Z equal to 3 because we consider a really high confidence level. So Z equal to 3. This is why we use 3 multiply the SP. This is the SP.
Okay, but it'll tell you that. It'll tell you what
If
you guys want Z to be.
okay, so if it didn't tells you anything, then you just use 3.
Okay.
And for the problem you have here, again, so because it gives you like, okay, this P chart is under this 95% confidence level, so 1.96, this is your Z. But if it doesn't mention anything, it will be 3. Sometimes we use 2, sometimes like this is like 1.96, like 2. This is sometimes we use also, but in general, typically we use 3. Okay. Very good coaching. Yeah. Okay, any other questions here? Let me give you a few, like 1 minute to review like what I just mentioned, and then let's continue. And when you review that, please feel free to find these forms. Then you will be able to insert your name to mention your participation for today's discussion. Okay. Let me copy again. So I just need to. Okay, so you can use either of them. They are the same link. I mean, same forms link. So you will be able to insert your names. Now let's continue for another questions like for chapter 13, which represents to the R chart and X bar chart. Okay. So the R chart, X bar charts, like if you measure like the diameters, the length, or the weight, so the numbers you connect will be continuous, like just like I mentioned, 1.11, 1.2, 2.2. So they are continuous. They are not always integer. Then you need to use R chart, X bar chart. And the logic is actually similar to P chart. So you just need to do some calculation to find the upper and lower limits, but the formula is different. So for the R chart, the R here represents the range. So we need to find the range, the average range. And this is like the average of the matrix you measure. So overall average. So let's take a look with the examples directly. So this is the examples here, and we have those samples, and this is the units in a sample. And my first question, what is the sample size? It's 25 or other number, or 4, maybe 5, or maybe 6. What is the sample size? Any idea? I don't see the link. Okay, so let me copy the link again to have you seen the link right now? 125? Okay, I like this number, but no. Sample size, it means like the size of samples. So it means how many units in sample for each sample. So how many units for each sample? Take a look at the table here. No link. 25, 250. Okay. Oh, sorry. No. How about this? 5 per sample. Okay, have you seen the links right now? I just like sent to the direct person, so sorry for that. Okay, great. So I'm like 5. Okay, so if I ask you sample size, that means like how many units in each sample. So now we have 25. This is the number of samples, which means like you have 25 samples. But if we consider the sample size, it will be 1, 2, 3, 4, 5. So for each sample, we have 5 units. So each unit in sample, this is like 5 units in each sample. So this is sample size will be 5. Okay, so 5 will be the sample size. And why we need the sample size? If we review like the formula here, like we have A2 and D4, D3, those numbers are the number like they are constants. So you don't have to calculate it. You just need to find the sample size. You just like find those numbers based on the sample size. For example, so if sample size is 5, then the A2 will be 0.58, 0.58, while D3 is 0, while the D4 is 2.11. Okay, so for example, like then how about like if sample size is 3, what is A2? If sample size is 3, what's value for A2? Take a guess, give me a number. Okay, very great, 1.02. And the D3 will be 0, while the D4 is 2.57. So when you do your homework, you just need to make sure like you figure out the sample size, then you will be able to get A2 and D3, D4. And except for those constants, you also need to find the average of X and the average of R. So if you do the R chart, then you just need to find the R bar, which is the average of R. So what is the average of R? R here represents the range. So this is the range. And for sample 1, we find like 5 units, and unit 1 is 10.6, unit 2 is 10.4, 10.3, 9.9, and 10.20. So the range for sample 1, we need to use the largest number, which is 10.6, minus the smallest one, so which is 9.90. So we use 10.60 minus 9.90, then we got 0.70. This is what we call range. Okay, so range equals to the maximum number minus the minimum number for each sample. So continue. Sample 2, what is the maximum? What is the largest number here? This one. Unit 5, so 10.33. We use 10.33 minus the smallest, which is 9.98. Then we got 0.35. Then you just like continue doing all the range. You can use Excel, like you just use like Excel to find that, or you can just use your calculator. You can do either way. And you just like find all the range for all the 25 samples. Okay, and then the average R, the R bar, always a short line above it. This is the average R will be the average for the range you find here. So you just find the average for all the range. Then you will be able to get 0.6. This is the average range. And once you got the average range, you will be able to get the upper limits and lower limits. So the upper limits equal to D4 because sample size is 5. So D4 equals 2.11, while D3 is 0. So you use D4 times like the R bar, which is the average range, then you got the upper limits for R chart, and the lower limits will be 0. Okay, so this is how we got the R chart. While the X bar chart. So the X bar chart here, this is the average numbers. So this is what we have. Then we just calculate the average for each sample. We just sum all the 5 together and divide by 5. So we calculate the average for those 5 units for sample 1. And then we will get 10.28. And we just continue doing that. Then we got 10.17, 10.07 for sample 3. Then we will get all the average for all 25 samples. And then you calculate the average for all the 25 numbers here. So you got the X double bar. So you got 10.21. This is the overall average. Okay. And once you got this one, you will be able to find the upper lower limits for X chart. So this is 10.21 plus A2. We just still back to this table. So sample size is 5. A2 equals 0.58. So 0.58 times R bar we found for like last step, we got the 0.60. So we got the upper limits, lower limits. And then you just plot. So you just plot like the numbers into the X bar chart and the R chart respectively. And the numbers you use to represent the samples, like for the X bar chart, this is the average. And for the R chart, this is the range for sample 1, sample 2, 3, 4 until 25. Okay, so just insert all of them into the charts and to see if you find any single point outside the limits. So for this 2 control chart here, how is it? It's in control or out of control? In general, like for a really simple way, like if you didn't find any single sample points outside the limits, it means in control. Okay, so it looks great. Okay, so this is all like, I mean, the problems like for the chapter 13. So if you open like your chapter 13 here, so the question 1 relates to P-chart. You just need to go over the formula for P-chart. Then you will be able to figure out like how to do that or how to do all the questions here. Question 2, it relates to R charts, X bar chart and R chart. So you just need to figure that out. And question 3, back to P-chart again. So you just do P-chart again. Okay. And it's also like, so this is what we have. And it gave you like 95.5%, which is 2 standard deviation, then the Z equal to 2. Okay, so this is like Z over there. And then the last thing I'd like to give to you for the homework for the chapter 13 is this one. So this is talks about like the acceptance rate. And if you find your textbook, it's actually on page 379. So this is actually where you can find the examples to finish the homework here, but I will give you a brief introduction as well. So for these types of questions, you just need to figure out a few things like what is the AQL, what is the LTPD. So the AQL here means the acceptable quality level. And for these questions is 13%. And LTPD, this is what we call the not tolerance percent defective. So this is the percent of the defective you accept. So this is the tolerance. And this question is 38%. The not tolerance percent of the defective. Okay. And once you figure out these two things, another things you need to figure out is the N and C. So if you open this exhibit, you will be able to see a C here and a N. So N means the number of units, okay? While C means what is your acceptance number? So if you produce 100, like what is your acceptance number? Like you feel it's still good. Like if you say equals to 7, which means like when you produce 100, like then you have 7 units defects, that's fine because this is under your tolerance. So this is the C. C means like the acceptance number, okay? N means the number of units. And once you figure out those 4 numbers, you will be able to finish the homework here. So this is the sample size. It's asking you about the sample size. This is then how do you find the sample size? You just need to find N. So the number of samples, this is sample size. And we have AQL, we have LTPD. So the first steps, you need to use LTPD divided by AQL, then you will be able to get this number. So why we need to find that? Because we need to find this one. And once you find that one, then you will be able to find the acceptance samples. And the N is actually equals to, so this is the N times, this is like what we got here, LTPD divided by AQL, like we use these numbers, then we got 2.923. This is really similar to here. So we find the numbers here, then you will be able to find, okay, N times AQL will be 3.981. Once you got these numbers, you will, because we know AQL is 13. So AQL here is 13. We got that. Then you will be 13%. So you will be able to find the N. N will be equal to 31. And this is what we call sample size. Okay. And then the C here, we just back to you. This exhibit here. So say when we find like if LTPD divided by AQL, this rate equal to 0.9 something, then the C equal to 7. So this is your acceptance number. So you will be rejected if the not more than 7 defects. This is what we have for question 4. So the logic for question 4 is like when we talk about the acceptance problem, then you just need to figure out what is the AQL, what is the LTPD. And once you figure out these two numbers, then you will be able to find the rate. So the rate for LTPD and AQL. And once you find this rate, you will be able to find C and N. And this is what we have for what is the question 4 ask for. So this is asking for N and this is asking for C. Okay, so this is all the calculations we have for the homework for chapter 13. Any questions? Okay, great. Then do you have any questions for today's discussion or for the assignments, for the canvas, for the contents you have for the management 6140? Any types of questions? Yes. Even like I mentioned, like sometimes I use the sentences if you read the description for the test. So I ask you use the notes for the last few calculation problems, but actually I announce you to use the notes for the entire exam. So you can take notes, but all the notes I mentioned is actually the physical notes. So it's not like the Word file, because like if you open a new file, like while you are taking the exam, the honor knock maybe kick you out. So that's the reason like I ask for the physical notes. And this is also like because if you take notes, like then you probably like understand some like the concepts, knowledges better. Like if you just copy paste like for the word file, you just like remember nothing. But if you take notes, then probably you know something else. So this is what I hope for, but I'm not like asking students to memorize too much stuff. So that's the reason like I announce the notes while you are taking the exams. So yes, you can use the notes during the entire exam, like including the multiple choices problems and as well as the true or false. Thank you. Thank you for asking the questions. That's a really good question. Like I only say 3 faces like for this Zoom meeting. I'm not asking you to open your camera, but I just want to say like all the 3 faces I am seeing, you just like feel so worried about this courses. No, you don't have to do that. Anytime if you have any questions, just let me know. Like I am always here to help you. So I know this is not an easy class, but you will be fine. Like just let me know. Like you can reach out me or my coach like anytime, like even the weekends. Just let me know if you have any questions. Okay. Yes, it will still be the 90 minutes. You will not be allowed to use Excel because all the numbers I used are really simple. So you don't have to use Excel. And the reason is also like because if you open the Excel, then the honor knock maybe kick you out. So it will disturb like your examining. So you are not able to use Excel, but you can use the calculator. I will post these recordings to the Canvas, so you will be able to find that under the module, the homework discussion. Yeah, the extra credits. And for the exam too, I will always use like the simple numbers, so it will not takes you too much time to finish the last few calculations, so you will be fine. Okay. Hey, any other questions? And do not forget to like insert the forms with your names. Like I will check that nature, like give you extra credits. Okay. Hey, hey, thank you. So if you don't have any other questions, I will finish our discussion today and see you next time. And I hope you have a wonderful rest of the night. Okay.
Thank you.
Yeah.
Thank you.
Thank you. Take care.